Good afternoon, all the students. Just wait for 1 minute. And now here we are going to discuss about whatever friction component. The last class we completed the numerical problems.
Hey.
Yesterday we already completed the fourth one, and now we are going to discuss about the fifth question. That is the page number 1 to 10. What is the fifth question? It is there. Yeah, all the students. That is the zero, the coefficient, the given. That is the printing mistake. The coefficient of the static friction. The question is starts with the not zero. Please remove that in the fifth question. The given are 0, the coefficient of static friction between the contact surfaces of the two bodies is a 1. The contact surfaces of one body support the other till the inclination is less than what? Okay, you know very well. The whatever the friction angle formula is, tan phi is equal to taken as, yes, what we are considered here, yes, that is taken as mu s. You know very well. Here mu s is given as what? 1. Then tan phi is equal to become what here? 1. Then phi is equal to become 45 degrees. Why? Tan 45 degrees is equal to 1. This is going to be the answer. The fifth question answer is B. Next, come to the sixth question. Come for sixth question. Yeah. Next, sixth question. Important one here. The sixth one. Level 2 question it is. Sixth one. What they given here? They given 20 newtons of weight is pressed between two hands. Each hand exert a force of 40 newtons. If the book just starts to slide down, coefficient of friction is what here? Now, then it will be what? It will become, there is a one textbook, it will be there. The textbook is influenced by the weight that is equal to what? 20 newtons. And here there is a what happened? Two hands are given the forces here. Here it will be given 40 newtons. It is also given 40 newtons. Okay, clear or not? Two forces are applied on it. Yes. And now there is a whatever the force exert, two hands is exert the force here. Okay, clear or not? Yes. Now the two normal components are giving the forces here, and here there is a one force is here is the working, another force is the here it will be works. Okay, got it or not? Now there it is what happened? The two forces are working. Then it will be want to become slide down at that time. Okay, when it is wanted to become a slide down, yes, there is a we have to find out the kinetic friction for it. Okay, clear or not all the students? Whatever the kinetic friction it is there. Yeah, here that will become F and F. This 2F is equal to the W. Okay, here it is F is the working. Here also F is the working. It is equal to W. Here you know very well F is equal to what? Mu into N. Got it or not? What is that? Mu into N here. Yes. Now there is a W value given, and there is a both side how much forces normal components 40 is working on it, and here automatically it will become what 2 into mu into N is equal to W. Got it or not? What we required here, the mu value required here. That is only we have to find out or not. We have to find out there is a whatever the coefficient of friction. What it is the coefficient of friction? There is a mu is equal to taken as W by 2N. W by 2N. Now, there it is a mu is equal to become what is the W value? W is equal to 20 newtons. 20 into 2 by 40. N value 40. Okay, got it. Both sides 40 we are applying. And now the mu is equal to taken as what? It will become 10. 10 by 40 is 0 cancel. It is become 1 by 4. Then mu is equal to 0.25. Okay, got it or not? The answer is what? 0.25. A. Answer is A for sixth one. Yeah, please note down it. Yeah, next one. Level 2, there is seventh question. If the block of mass is a 10 kgs is on a rough horizontal surface, the horizontal force 4 newtons is applied on it. If the coefficient of static friction between the two surfaces is 0.5 force between the two surfaces in contact. Yes, what is the what we have to find, a block is a 10 mass 10 kgs is a rough horizontal. Here horizontal force is a 4 newtons applied on it. If coefficient of a static friction is a given, frictional force is a what it is between the two surfaces. Here they we have to find out here simply. Yeah, what we are considering here, the mass of the body is equal to taken as what? The given 10 kgs is given, and as well as there is a whatever the horizontal force is working, how much? 4 newtons is working, and mu is equal to taken as 0.5. Okay, the diagram is a very important to the whatever the frictional forces problems are there here. How to draw the diagram here? There it will be works like this. Okay, now the weight is in a downward, and here it will be works up down upward. The n is, and the frictional force in the horizontal manner it will be works like this, and whatever the horizontal force is the work here. Okay, FH horizontal force, and here there is a static force friction is acting on it, and at where it will be acting at a rest only it will be acting, you know very well. Okay, where the static force is acting at a rest. That here, as first we have to find out what is the weight of this particular body. They given what 10 kgs, and as well as at that time the weight of the body is acceleration due to gravity for that body is a g. G is equal to 10. That is the n is equal to mg, and we don't know what is this mg here. N is equal to what happened here? M into g. Here n is equal to taken as what is the m value? 10. What is the acceleration due to gravity value? Is 10. That is become 100 newtons. Okay, now what is the weight of it? Yes, weight of it is taken as 100 newtons. And now there is a next we have to find out what is the frictional force here. You know very well. The limiting force is equal to taken as, that is only, yes, frictional force small f is equal to taken as mu into n. What is the mu value here? Mu value is a 0.5. Got it or not? As what is the n value here? N value is taken 100. Okay, now it will become what? 50 newtons. What is the limiting force here? 50 newtons. Got it or not? Applied force, whatever there here. What is applied force here? It is 4 newtons only. Yes, applied force is equal to what? Applied force is equal to taken as, yes, 4 newtons. It is taken as 4 newtons. It is less than the our frictional force or not? Yes, whatever the applied force is there, it is less than the frictional force or not? Yeah, there is a applied force FH is less than, yes, 50 newtons. Got it or not? Now there is a, so the friction force will be S equal to applied force only. Got it or not? Here there is a force. This friction is a work set where static friction. The friction, how much it will be there? Yes, static mode only. There is the applied force is only become what here? Static friction. That's why our answer is become 4 newtons. In case it is less than, whatever this force is less than this, okay, that is only become the frictional force for us. Okay, now the body is the what? For this weight, it will be rest. Okay, that's why that is whatever applied force is there, that is only become the frictional force. Got it or not? Yeah, please note down here. This is F max actually. Yeah, next to 8th question. Now the student, the printing mistake is there in a 8th question. There is what it is, you know, a 100 kg of body is resting of a horizontal plane having coefficient of friction 0.2. A force of 196 is required to pull the body horizontally. The acceleration developed by the body is, okay, the acceleration developed by the body is what actually? Yes, now there is what we are consider 100 kg of a, yes, a resting of the on a horizontal plane having coefficient is a 0.2. Okay, na? And how much force is required to pull the body? The force is required to pull the body is the 196 actually. Yes, and answer is it is 0. Okay, how it answer is 0? No, both the forces, applied force and other the frictional force, is the both are become same here. Got it or not? That is why that it is become 0. Now mu is equal to, you know very well, F is equal to what? A small f is equal to mu into n. Here n is equal to how much? Mg. Got it or not? N is equal to how much it is? Mg. Now there is a f. What is the mu value given? The mu value is given as 0.2. That is only or not? And m is equal to also they given how much? 100 kg. Yes, g is equal to, you take 9.8. Okay, exactly. 9.8 meters per second square. Now m is equal to become what? Mg. In the place of mg, you have to substitute here. 100 into 9.8. Okay, got it or not? Now how much it is? 100 into 9.8. Yes, it will become 980. Got it or not? 980 or not? What it is? 980 newtons. Yes, n is equal to 980 newtons. Now this value substitute here. Yes, what is that? Capital N comma mu substitute in f, small f. Okay, now what is that? F is equal to, what is the mu value? 0.2. What is the n value? 980. It is a 196 or not? Okay, clear or not? It is also written as 2 into 10 to the power of minus 1. It is written as 980. Okay, clear or not? Now 2 into 98, 10 to the power of minus 1 into as here it will be written as 98 into 10 somewhat. Written or not? 10 to the power of minus 1, 10 to the power of plus 1. It will be 0, 10 to the power of 0 is 1. It is 98 or not? Now it will become what? 196. 2 into 98 is a 196. This is a what? Frictional force. Applied force is how much? Applied force is how much? Applied force is here 196 they given already. We have formula. The force is applied. Total force is applied is equal to taken as, yes, what is that? Applied force minus frictional force. Applied force minus frictional force. Now both are same or not? Force is equal to also written as MA or not? Force is equal to what? MA according to Newton's second law. Now the applied force is equal to how much they given? 196. How much will get frictional force? 196. It is become 0. MA is equal to 0. M not equal to 0, na? Then what is that? A equal to 0. Got it or not? I hope you got it here. Why M is not equal to 0? Mass is never become 0. Okay, na? Mass should be, at last some value will be there. Here 100 kgs already they given. Okay, na? That's why the A is equal to become 0. Understood all of you? Yes, this first you have to find out a frictional force. Then you check how much force is applied on it. In case it is applied force is a greater, this will be lesser. The acceleration may available. Okay, na? When the body is accelerate, when there is a applied force is a greater than the all opposing forces like a friction, weight, and all these things. Here both are same. That is why the body not accelerating. It will be in a rest only. Okay. Yes. No doubt. Yeah. Next question. There is a 9th one. What is the 9th question we are consider? There is an eraser is there. One eraser is weighing how much? 2 newtons is placed against the blackboard with a force of 5 newtons. If the coefficient of friction is 0.4, the mass, the force is parallel to the blackboard is required to slide the eraser upward with a uniform velocity. Okay, we want to erase the whatever the written it is on that. Yes, the downward force acting on eraser. Yes, the downward force acting on eraser is equal to, it is equal to what we are consider frictional force plus weight. Yes. Yeah. How to find out the frictional force? There is a what they given. The values are given. There is a normal component is given. and as well as the weight is already given. Here weight is equal to how much they given? Weight is equal to further 2 newtons. Got it or not? And now how to find out frictional force here? The frictional force is equal to taken as it is equal to taken as mu into n. The n value mu is equal to how much? Mu is equal to 0. The frictional component is a given na. Yes, coefficient that is a 0.4. N is equal to 5. Okay, clear or not? Yes, now you have to substitute frictional force is equal to how much? Frictional force is equal to taken as 0.4 into 5. Got it or not? Yes. And now 4 into 10 to the power of minus 1 into 5. It is a 20 into 10 to the power of minus 1. It is become what? 2 newtons. Got it or not? It is 2 newtons. And now there is a what is the answer? Answer is become 4. Why? Because frictional force is equal to what? Yes, downward force is equal to or otherwise directly write it is equation number 1. Okay, now substitute. Yes, W and as well as the frictional force here. Okay, clear or not? This is the taken as small f. Okay, now small f is equal to 2n and W is equal to what here? That is the W is equal to 2n. That all substitute here in this one. What will we get? It is equal to taken as downward force. F downward is equal to taken as how much? Frictional force 2 newtons. And as well as there is a what is this? 2 newtons. Totally how much? 4 newton. Answer is become what? Downwardly we are used how much force to erase it? 4 N. Answer is C. That answer is C. Yeah, next we are doing the 10th problem. It's a very easy one. Listen carefully and note it. A time completed. 10th problem. Once check it. What is the 10th problem they given? A block of mass 2 kgs placed on the floor and the coefficient of static friction is a 0 point. If force 2.8 newtons is applied on the block parallel to the floor. The force of friction between the block and the floor is what? Actually. Here there is a mass of the thing is the 2 kgs are given and as well as there is again you have to find out a frictional force. What is the frictional force? Small f is equal to taken as yes mu into mg. Here f is equal to what is the mu value? 0.4 no? Yeah, 0.4. What is the m value here? M is equal to 2 kgs and the g value taken as 10 here. Okay, in this problem 9.8 before that we are taken, but it is become what now? There is a 10 into 0.4 into 10. 4 into 2, it is become 8 newtons. Answer is not 8 newtons. All the students listen carefully. According to this problem, the applied force is how much? 2.8 newtons only. Yes, it is always F net is always less than or equal to Yes, applied force. Okay, clear or not? What we have to consider here, small f is less than or equal to what? It is should be less than or equal to F net. Got it or not? Yes, and here that is why here very far greater than. That's why for a static, what they given? Static coefficient or not? What is given here? Static friction only given. For a static friction, yes, force should be less than the 2.8 or equal to 2.8. It is what given here. F is given as greater than F net. Okay, clear or not? According to this problem, F is greater than F net. In that our answers, they given 8 newtons, they given 2.8 newtons, and they given 2 newtons, they given 0 newtons. 0 newtons is not a correct. Okay, clear or not? Yes, 2 newtons. May answer it is not it is. Why? Because it is less than the applied force. Okay, now yes, and because of that, it will be body the yes, not a not application that particular our forces. And 8 newton, the body is a moving. The body is a moving nothing but there is a no static friction. Na? Here, in case it is a given kinematic coefficient, it will be become answer. 8 newtons only become answer. But answer is what? 2.8 only. Okay, clear or not? Yes, the for static friction, body should be equilibrium. Body should be equilibrium. Hence, 2.8 newtons is only as correct answer. Yes, force applied is how much? For this, we applied 2.8 newtons only. Yes, answer is it not possible. Yes, it is not possible. Got it or not? I hope you got it. There is these are the problems for today. And once check it, the last problem. Yes, don't confuse about this. Yes, you have to yes concentrate on that particular problem. Yes, what they given static coefficient. It is a what it will be 8 newtons. What the applied force is given here 2.8. The body is a moving now. Okay now. Yes, there is a moving towards that applied force only, but it is given static. That is why bodies are not a moving. They not said moving body here. It will be contained on a floor. Okay, now that is why there is 8 newtons is not possible to work on it. The body and floor should be equilibrium. Okay, clear or not? When it will be equilibrium, at that time only we said it is a static coefficient. Otherwise, it is not a possible. Yes, we not given any relation when there it will be under the moving. At that time, there is another type of a friction will be there, that is a kinetic friction. Okay, now for given values, it will be not possible to get a 8 newtons. Okay, now yes, and it will be contain the same applied force only. Okay, please note down. Thank you, students.